To continue, since x can be any number, I'm going to pick a number that's going to eliminate one of those unknowns. I don't know a or b, but if I let x equal -1, this becomes 0 times a. A is eliminated from my equation. When I plug it in, -1 minus 4 is -5. -1 plus 5 is 4. I can solve for b. Now I know part of the equation. What would be another good number that I could plug in that might help me solve for a? If you said x could equal -5, then you were thinking the most efficient way possible. You could plug in other numbers. You could even get a system of equations. If you plug in a number 2 and 3, you'd have an equation with a and b and another equation with a and b. And you could solve that system of equations, but that's not quite as easy. I like this way better. So that means up top, we can rewrite this original equation as 9/4 over x plus 5 and -5/4 over x plus 1. Once again, why is this an advantage? Here's why. What's the integral of this equation? The answer being, I don't know. But if we integrate these smaller equations, then they become really easy. I have a coefficient of 9/4. The rest is just a plain log. I have a coefficient of 5/4. The rest is just a log. Whoops, lost the plus c on the end there. I guess you could see it if I go like that. So that's much easier. And that's partial fractions. Let's take some of these and break them up. Here's a new example, and it looks like it could almost be an inverse tangent if we were completing the square. However, it doesn't quite work. It would give us u squared minus a squared. Just trust me on that. But we're going to do a partial fraction decomposition. Step 1, let's factor the. Step 2, let's write it as separate fractions using each factor. Step 3, let's put in some variables for the numerators there. Since these are both linear, we'll just put in a number. And by a number, I mean I'm putting in a variable a and b that represents a number. There are no variables up in the numerator. Step 3, let's multiply through by the common denominator, which is the quantity of x times x minus 8. When I multiply through, remember, multiplying by this first term, what will divide out? The entire denominator. What part will divide out here for this next term? The x's. And then finally, what part will divide out of this third term? When I multiply these here, the x minus 8's will divide out. Now I've got a much simpler equation. I just need to solve for a and b. Let's pick out some numbers we can plug in that might help us solve for a and b. If you picked out 0 and 8, you are a smart little bumblebee. Plugging in 0 is going to eliminate b altogether, and that will allow us to figure out that this side is going to be 4 equals -8a plus 0. If you picked out 8, that also works great because now I'm going to get 4 equals a times 0 plus 8b. And now I can solve for a and b. Easy enough. And now our original integral is much easier because I'm going to rewrite that as a decomposition of fractions. It should look like this. Notice it's in the form a over x plus b over x minus 8. Those two fractions are much easier to integrate, and they're both logarithms, making it simpler. Now, this last step, I'm just playing with you. I'm seeing if you remember all your logarithm rules. If there's a 1/2 out front, that means the square root of x. And if there's a 1/2 here, that means the square root of x minus 8. Adding and subtracting means multiplying or dividing. That is your final answer there. Although, I still accept this. You just have to watch out. A multiple choice question on the AP exam might show the final answer this way or that way. Recognize them both. Thanks.